In these videos, I'm going to walk through the 10.6 review, focusing primarily on the first couple pages and then a little bit of focus on the end, but mostly on the first three because these are the newest things on this summative. So the first question has this ball thrown in the air. We're asked to find the key features. Keep this list of key features handy. All of these, whenever it says key feature used, should use one of those as an answer, okay? So that has to be in words. It says, how long is the ball in the air? The entire journey is part of that part of the story. So when is it in the air? Well, it starts at 0 and ends at 3.61. So how long is it in the air? 3.61 seconds. You might be tempted to say that the key feature should be the x-intercept because we see that here, but that's not the case because it's in the air this entire time. So we need to talk about not just one point, but the entire interval. This is the domain. So think about, is your answer coming from only one point or is it coming from an entire section of the graph? Remember that our intervals are domain, range, interval of increasing and decreasing, and the individual points are vertex and the intercepts. When does the ball hit the ground, however, that is only 1 point. That's right here, 3.61 seconds. So even though we have the same answer twice, they're coming from different parts of the graph. This is the x-intercept. All right, next one says when. If I see when, I know that that's time. So I know my answer is going to be in seconds. Apologize for my handwriting there. When is it at its maximum height? Maximum is the highest point. So when is that? I look here on the graph. That's 1.305 seconds. And that is our maximum, which is from the vertex of the graph. So vertex is our best answer there. And what's the initial height of the ball? That's talking about right here. Initial height is our y-intercept. Initial always means at the beginning times 0. So our initial height is 7.22 feet. Make sure you're paying attention to the units. Next one's about a pelican diving into the Gulf to catch a fish. So let's answer the same sorts of questions, but be precise here with them. Initial height of the pelican is the exact same type of question as what we saw in the last one. Initial, right at the beginning, 0.20 is the point. So which part of that's the answer? Well, the initial height is 20 feet. It's the y value. This is the y-intercept. How long is the pelican under the water? That's a very specific part here. That's this here. Okay. I know that I said a moment ago that the intervals, right, come from more than 1 point. Usually that's true. But does this match our interval of increasing or decreasing or domain? The answer is no. I don't love any of those for this particular one. I think that this comes best from our x-intercepts. If you can't answer with one of the intervals though from the box, let's do it. So how long is that? I need to subtract these two values. If I do that, I'm probably going to need to use a calculator, and that's okay here. So 15.774 minus 4.226 is 11.548 seconds. When does the pelican, okay, I see again that word when, that means we're doing time. When does the pelican reach the furthest point under the water? That happens right here at 10 seconds. Now that's the x value. We don't have to worry about the negative here because there isn't one in the x value. That is part of the vertex. When is the pelican swimming up to the surface of the water? Which part of the graph is that? Okay, when means we're dealing with time, but swimming up is not just 1 point. It's this entire region of the graph. So that is an interval, in this case, of increasing, which means when we answer the question, we say from blank to blank seconds. In this case, 10 to 15.774. And then when does the pelican first enter the water? That is 1 point. That is an x-intercept. Which one first enters the water? Right here, 4.226 seconds. All right. This one doesn't have the context, so we've got to just answer the questions. So what is the domain of this graph? I see, domain is our x values, right? Domain is x values. And if I'm going to use this number line to help make like a projection, right? So it exists everywhere here. And then I see this arrow pointing down and left, which really means we keep going left forever. And this arrow on the right tells me we keep going to the right forever. So are there any x values that cannot be used? The answer is no. Every single x value will show up somewhere on this graph. So we can say all real numbers is the domain. Some folks might write it this way, from negative infinity to infinity. But those arrows, despite whether they're pointing up or down, are pointing to the left and right as well. Range is our y values from bottom to top. So where is the highest y value? Looks like right here at 9. Everything down below it. Those arrows are pointing down, meaning it goes down forever as well. So my range here is from negative infinity up till 9. Is 9 a height the graph actually hits? Well, it's a closed circle. Yes, it has a height of 9 at the point 19, so I'm going to use a square bracket. When we talk about intervals of increasing and decreasing, that point is not usually included because at the end point of a section, it's neither increasing nor decreasing. So let's do that one next. Interval of increasing, I'm going to do that one here in green. That's increasing because it's going up and right despite what that arrow shows. It's going, we can think of traveling left to right and going upward in that section. And so from an x value of negative infinity up to an x value of 1. Again, at this point right here, it's not increasing anymore. It's not decreasing anymore. It's just where it changes. That's what a vertex does. Okay, and then we've got interval of decreasing, is this section. Where does that occur? That starts at an x value of 1 and goes to an x value of positive infinity. Cool. X-intercepts, where the graph touches the x-axis. There's 2 of them here, negative 2, 0, and at 4, 0. Notice we don't have to put a union in between them. We could just put a comma. They're not intervals. Y-intercept, it's the point 0, 8. And there's only 1. Okay. Equation of the axis of symmetry. The axis of symmetry goes right through the vertex. That's a vertical line, so x equals 1. And the vertex is at the point 1, 9. That vertex is the highest point of this graph. So we say the absolute maximum, the highest point anywhere on this graph is 1, 9. But the answer, it says minimum value. So maximum value is the highest point. We're just going to say 9. Value is just the y coordinate. Absolute minimum does not exist. Because that arrow means it keeps going down forever and forever and forever. It never stops going down. There's never a single lowest point it gets to. Okay. Rolling on to the next page. These are review topics, so I'm not going to spend a ton of time here, but pay as close attention as you need. X-intercepts here are at negative 5, 0 and at 3, 0 because negative 5 makes this first factor 0 and the second factor is 0 when you plug in 3. So I'm going to plot those, negative 5, 0 and positive 3, 0. Equation of the axis of symmetry, right in between those is x equals negative 1. which means the vertex is -1, comma, -4, and +4 is -16, half that is 8. So the vertex is -1, 8. Looks like that. Our a value is -1/2. And if I plug in 0 to get my y-intercept, it's not going to be a whole number, okay? It's going to be 0, comma, 7.5. You can run that calculation. You can either plug in 0, or we know that because the a value is -1/2, we go right 1 and down 1/2 from that vertex. Okay. We could add 2 more points. Normally, our quadratic table goes over 2 up 4. But since we're multiplying that by -1/2, that means down 2. So left 2, down 2, right 2, down 2 from the vertex with symmetry. The graph looks something like that. Okay, number 5 says plot 2 points on each side of the axis of symmetry. That's a reminder of 5 points is what we're looking for. Axis of symmetry here, reminder x equals opposite of b over 2a. In this case, that's -8 over 2 or -4. So -4, we have our axis of symmetry. Mark that with a dotted line. Substituting in -4, that'd be 16 minus 30 is -16 plus 7 is -9. So 4, -4, -9. Our a value is 1. Our y-intercept is 0, comma 7 because of the constant term. So I can go ahead and just plot that one and go symmetrically. Say this distance right here is 4. So I'm going to go 4 on the other side to make a point. Since the a value is 1, I'm going to go right 1, up 1. And that's all we have to do. We could keep going. Right 2, up 4 from that vertex. We could go right 3, up 9 from that vertex. Those are all points that are on here as well. And you really get to see the shape of this quadratic. You only needed to have 2 points on each side of the axis of symmetry. The y-intercept is a good one that helps you get one on either side. Okay, number 6. First thing we always look for is a common factor. Both of these have an x in it, so I know x is going to be part of the common factor. And both of those are divisible by 9. So 9x is the common factor of both terms. And then I think, what would I have to multiply 9 by to get back to 27x squared? I need another x, and then 9 times 3 is 27. Same idea to get from 9x to 63x. What do I need to multiply that by? Well, it needs to be positive, and 9 times 7 is 63. So this is our best answer right here. This is completely factored because what's left over is a linear binomial. Number 7, no GCF, but x squared is a perfect square, 81 is a perfect square, and it's subtracted. So I know I can do a difference of squares here. X and x make x squared. 9 times 9 makes 81, plus and minus. Number 8 is also a binomial. There is a GCF here. Both of these are divisible by 2. So I'm going to pull out a 2. 2 times 5 is 10. We need that x squared to come along, plus 3. What's left behind is a binomial. It's still quadratic, but there's no difference of squares here, so we are done. Number 9, difference of squares. Because 9 is a perfect square, 1 is a perfect square, so I need 3x and 3x, 1 and 1, plus and minus. Number 10, difference of squares. No common factor here. 36 and 25, they're what we call relatively prime. No greatest common factor here. So 6x and 6x gives me 36x squared. 5 and 5 gives us 25, so plus and minus. 11, 2 terms, binomial. Is there a GCF? Yes. What is it here? Both of these are divisible by 6. So pull out a 6. 6 times 4x gives me 6x, or it gives me 24x. 6 times -7 gives us -42. Double check, is there a GCF inside the parentheses of what's left over? There is not. This is our best and final answer. Number 12, binomial, look for a GCF. Right now, it's not a difference of squares. So the question is, can we factor this really much at all? Both of these are divisible by 10. Let's do it. 10, what's left behind is x squared, 1x squared, minus 4, and oh my goodness, this right here is a difference of squares. So to finish factoring, I'm going to keep that 10 out there. I'm going to factor that x squared minus 4 as well. X and x, 2 and 2, plus and minus. This right here is completely factored. So, number 13. Well, both those terms are negative, so I know I'm going to want to factor out a negative. What's the greatest common factor between 12 and 50? It is 2. So I'm going to pull out a 2, a negative 2. That's going to leave me with 6x squared plus 25. Not a difference of squares, so we are done at that point with this binomial. 14 is a trinomial, which means if it factors, we're going to factor it like this. 15 is also a trinomial. So is 16. So I know, and 17 as well. All of those, as soon as I have 3 terms, if it's factorable, is going to use 2 sets of parentheses like this. To get x squared, I know it's got to be x and x. Bunch of different ways to get 40, but the way that we're looking for it so that we get a negative 13x, it's going to be negative 8 and negative 5. In 15, 3x and positive x are what we need to get 3x squared. I also need to get negative 8. So I know to get negative 8, I'm going to use either negative 1 times 8, or negative 2 times 4, or negative 4 times 2, or negative 8 times 1. And we're going to pick strategically which of those pairs I'm going to use to get negative 2x in the middle. Okay, this takes just a little bit of thinking it through. If I put the negative 2 there, I'm going to get negative 6x and positive 4. It's going to be positive 4x, which overall results in negative 2x. That's what we wanted. Cool. 16. X times x is x squared. To get negative 44, I'm going to go negative 11 and positive 4. If you do a different combination, you're going to get a positive 7x, and that's about all you can do on this one. Now, in 17, I'm not going right to factoring this because I don't want to deal with 48 and 22 because I have a greatest common factor here. 2 divides every one of these terms. Let's pull it out. So 2 is going to go there, and what's left behind can still be factored. X times x gives me x squared. 24 is 8 and 3. And that's the pair that's going to give us 11. If you don't factor out that 2, it's not completely factored. Good luck and answer any questions you have.